Hi, my name is Heriberto Rivera Cerezo. I am a student. Uh, I am a doctoral student at the Universidad Autónoma de Nuevo León, and I am going to present my work, Influence of Thermal Treatment on the Susceptibility to Localizer Corrosion in Aeronautical Grade Aluminum Lithium. For many years, aluminum alloys have been the most widely used materials in the aeronautics aluminum alloys. Aluminum alloys are materials of fundamental importance for structural application due to their low weight, workability, relative low cost, among other advantages. Also, the use of composite materials has been increasing as, as shown in figure 1, which present the percentage of use of the different types of materials in Boeing 787 aircraft. All alloys continue to be important materials for these applications. The aluminum copper alloys are the primary alloys used in aircraft structural application, where the main design criterion is damage tolerance. The aluminum alloys of the 2000 series was main alloying element is copper, also contain magnesium, which aids in the precipitation of hardening phases such as aluminum 2 copper and aluminum 2 copper magnesium. This precipitation provides better mechanical properties to the alloy. Of this series of alloys, 2024 T3 is one of the most widely used alloys in airframe construction. However, a disadvantage of this is that the precipitated phases can act as anodic site, drastically reducing the corrosion resistance. On the other hand, aluminum lithium alloys belong to the 2000 series, copper as the main alloying element, to which lithium had been added in an amount less than 1.8% with the purpose of reducing its density, since the density of lithium is very low, 0.54 grams per centimeter cubic. It has been observed that for every 1% of lithium added, the density of the alloy is reduced by 3%. In addition, the elastic modulus is increased by 6% for every 1% of lithium added. These alloys are excellent materials for aeronautical applications. Like most aircraft or aerospace grade aluminum alloys, the mechanical properties of this generation aluminum lithium alloys are a direct result of the presence of precipitates in their microstructure. The effects of in heat treatment in alloys is the improvement on their mechanical properties, strength, ductility, and fracture toughness, and also to improve corrosion resistance. In this work, an investigation was carried out on the corrosion performance of two alloys, the 2024 alloy, traditional in aeronautical application, and the aluminum lithium alloys 2055 and 2099 alloy, which are relatively recent. These alloys, subjected to three different thermal treatments, were tested in the presence of three different electrolytes. So, the objective of the work is determine the, the influence of heat treatment on the susceptibility to localized corrosion and its propagation mechanics in aeronautical grade aluminum alloys. Sorry. The alloys under study were obtained in the form of a bar from which they were uh, materials and metals. The alloys under study were obtained in the form of a bar from which they were machined to obtain the samples in the form of slices of 8 centimeters in diameter and 2 centimeters thick. These samples were subjected to heat treatment to obtain the three alloys 2024, 2055, and 2099 under three heat treatment conditions T0, T6, and T8. Once the alloys were obtained under the three heat treatment conditions, they were prepared metallographically to be characterized by scanning electron microscopy, CEM, and element analysis by energy dispersive X-ray spectrometry, ADS. After this analysis, the samples were subjected to Vickers microharness test, applying a load of 100 grams. Here I show the standard under which these tests were performed. Another group of samples in the three heat treatment conditions were prepared to be subjected to corrosion tests. The electrochemical noise techniques was used. The tests were performed in the presence of three solutions: sodium chloride at 3.5%, hydrochloric acid at 1%, and sulfuric acid at 1%. The results of this test were analyzed visually as well as analysis by means statistical parameters. Here I show the schematic diagram of the experimental setup for this electrochemical noise test. Result. The nominal composition of the alloys under study is presented in Table 2. The results of the microharness test conclude that the high-head microharness values corresponds to the alloys on T8 condition. This is due to the cold working to which the materials is subjected during this treatment, since it increased the density of the locations. The alloys in heat treatment T0 obtained the lowest microharness values. This is due to the fact that during the annealing treatment, the displacement of this location and the reduction of residual stresses are generated. The SEM images shows, among other things, the large number of precipitates in the 2024 alloys with respect to the other alloys, especially in the T0 and T8 treatments. The high percentage of copper in the precipitates, the high percentage of copper in the precipitates is also observed above the percentage of aluminum. The 2055 alloy presented cracks generated at the grain boundary. The percentage of copper in the precipitates is lower than in the 2024 alloy. The visual analysis of the electrochemical noise results shows unstable signal with high amplitude transient in the 2024 T0 and 2024 T8 alloys, which can be attributed to the amount of precipitates on their surface and may be generating galvanic couplets. This is confirmed by what the localization index values indicate in the statistical parameters analysis tables. Localized corrosion. Conclusions. 2024 alloys showed higher corrosion rate, especially in presence of sodium chloride and hydrochloric acid. The TA treatment provides better mechanical properties to the alloys, while the T0 treatment provides lower hardness values and greater susceptibility to corrosion. The high copper content in the 2024 alloy with respect to the aluminum lithium alloys generates greater susceptibility to corrosion due to presence of intermetallic phases such as the S phase, aluminum 2 copper magnesium, and the grain boundaries, which have electrochemical activities different from those of the surrounding matrix. The T6 hard treatment caused cracks to form in the 2055 alloy, probably due to the quenching process. Thank you.